I'm Phil, and today we're going to do our second session in the robots course. That is, we're going to look at clocks. But just to have a look at the overall program, in our first session, we looked at the name badge, and this was really a hello type program. Uh, we had a couple of projects, and we looked at how we could program the computer called the Atom S3R. So here's our learning objectives there, just to review them. We looked at introducing the hardware, the peripherals, and we could use bases or units. We looked at software development and the IDE called UI Flow. But it's actually UI Flow version 2. And we looked at the different panels on that. Then our two projects, one was to get used to burning firmware so that we could accept and download programs from our UI Flow. And our second project was a Hello World project where we made a name badge using the small computer, the Atom S3R. And that's what we did last time. Now we're going to have a look at clocks. And overall, we're going to introduce some concepts, and they are how to start up and initialize your hardware. We'll go on the forever loop. We'll look at event programs using interrupts and callbacks. We'll have a look at real-time clocks and the APIs and the libraries. We'll have a look at setting up Wi-Fi and also time using the timer and RTC, which stands for real-time clock. And we'll have a look at a watchdog timer. We'll mention scheduling and also a real-time operating system, although that's much more advanced in terms of what we want to do. Okay, so hardware-wise, we're going to use the Atom S3R, and all the components that we need are all built into that computer. So let's have a look at the projects we're working on. We've got simple timers, and we'll go through these gradually. Then we'll look at a timer and a more advanced clock. We'll look at a watchdog timer, and most of the extensions we won't have a lot of time for. I'll demo those at the event. And the event is at Chatswood Library on the 21st of June 2025. And in our extensions, we'll look at the internet protocol called NTP. We'll demo a time timer, and we'll look at how timing is used in music and how you can create simple music programs. We'll look at time for debugging and debugging, how long it takes us to execute some code. Then I'll have a challenge for you. I won't show the code for that, and the challenge is that you make your own scheduler based on priority, start time, and a flag, whether it's going to be repeating and how often it repeats. And finally, we'll have a look at creating a smartwatch with the Atom S3R, and that will be coupled to your smartphone, and it will maintain accurate timing and give you notifications, just like a full smartwatch. Okay, so let's start off with the first one, which is the simple clock. And the objective here is to maintain time by incrementing the seconds, minutes, and hours. So we're going to have a very simple algorithm for doing that. And we're going to show the time on the Atom S3R LCD. In coding, we're going to learn about variables, and we'll look at logic and UI. The extensions should be down here. The extensions, we'll be looking at how we can use extensions or APIs to help us with our coding. Software-wise, let's have a look at the UI flow. Uh, we're going to paint a simple program, or we're going to paint these labels. The first one is our text label. Then we've got our other labels, and they'll be assigned to the time in units of hours, minutes, and on the bottom, seconds. So here's our code for doing that. And we might go across in a minute and have a look at how we can create that. So there's our UI right on top, and there's our code. Our code on the right starts off on the left with setup, and we set up the variables, and we show those on the LCD screen on the three labels. Then we're going to update. Now, and note how we do it. Most of the time, we're just going to put our computer to sleep for a second. And when that's finished, we change the seconds by one, and we then put that on the label 2, which is on the bottom of our LCD. And if the seconds are 60, we set that to 0 and change the minutes by 1 and set the middle label to the minutes value. And if the minutes are 60, we set that to 0 and change the hours by 1. And the top label, or label 0, we set the hours to that. And if we've gone round and we're at 24 hours, we then reset the hours to 0. So we've got a very simple program. Let's go to our online and have a look at that now. So we've just gone across to the website for M5 Stack, and we choose software, and we go to the bottom one called UI Flow 2. Now, once we go there, we can bypass most of these screens. So I'm just going to bypass and cancel that one. And I'm going to make sure that I've got the correct device. So it's already set for the Atom S3R, but there's about 30 odd computers that you could set this up for. Okay, so we're going to confirm that. And the program starts off by giving us two envelopes. The one on the left is the setup, and it only executes once. And the one on the right is called loop, and it repeats that loop forever. So we're going to start off by creating variables. So our first variable is going to be seconds. Then we go to minutes and hours. Then we just grab the first one, which is on under variables. We've got all of our new variables, and we have now two new commands that we can use in this toolbox area. So we'll start off with seconds, and we'll duplicate that, and we're going to make the next one minutes, and the next one will be hours. And we're going to set the time by going to maths and grabbing a number, and we'll duplicate that and duplicate it again, but we'll start off the hours at 2 o'clock, which might be the current time. Now we're going to paint our screen. So we go over to the left, and we click on this button on the top right in the first left panel and we get a bigger picture for our screen. We're going to put the title in and we'll give that the name of the program, which will be just simple clock. And we could put 1 because it's our first version for that. So we've got the title. Now we'll put the labels. So we've got label 0. That'll be where our hours goes. Our minutes will go there. And we're going to stagger these. So we've got hours, minutes. Just make it simple. You can make these bigger if you want to, but we'll just leave them as they are. Now we've got our labels. We can program them under UI. So if you go to the toolbox, which is in the middle area, go to labels, grab the first one, and that will be the hours. So we've now got hours as a variable. We've already set it, and we'll just duplicate that. And once more, but we're going to set the middle label, or label 1, will be minutes. Then the other one will be, the bottom label will be seconds. And now we're going to go on the loop, and our loop's going to start off with time, and we're going to sleep for 1 second. So we put that under loop, and then we're going to change our variable seconds by 1. So we look for variables, set, we've got hours, but we'll select seconds. And we're going to make that a 1. So we go back to maths, select a number, and set the seconds to seconds plus 1. Now we can either do that, or there's a quicker way of doing it, which is just change by 1 the seconds. And we'll just get rid of that. Now we're changing the seconds by 1. We're going to show what the seconds are on the label. So we just repeat this one, duplicate that one, bring it across, and we're going to do a little bit of logic now. So we go to logic, and we'll select if, do, else. And the first one is what happens if the seconds equals 60. So we go back to logic, and we're going to select the equals. So we'll bring that down, and we've got 2 variables that we want to consider. We've got the seconds, and we've got a number from our maths, which is 60. So if the condition is satisfied there, we're going to set the seconds to 0. So we'll duplicate, we've already done that one, so we'll put it back in, and we're going to change the minutes by 1. So we'll select minutes and change that. And we'll show the minutes now. So we'll duplicate that label and bring it under, and that will be set the middle one, which is 1, and that will be minutes. Okay, now we're going to have a look at what happens with seconds. So it's really just repeating this one and just changing some of the variables. So we'll duplicate that and pop it under there. And if the minutes equals 60, we're going to set the minutes to 0 and change the hours by 1. And we'll set the, we've got minutes for our first label. We're going to set the hours. So that's going to be the first one, and we'll look at the hours there. So we're changing the hours and updating the hours on our clock. And the next one is what happens when at the end of the day. Well, we'll go back to logic, and instead of using the larger if, do, else, we'll select the small one. And here we're going to have a look at hours. So we'll just duplicate that one, put it under, and if the hours equals 24, we then set the hours, set the hours, duplicate that one, set the hours to 0. Okay, so I think we just about finished our program. What we have to do now is download that to our computer, the Atom, and we can see it perform on the screen. We're ready to download our first program, the Simple 1B, and what we're going to do is go to the screen and run the program. So we're just looking for our program now. Run that. We're going to pair it with the Atom. Our Windows computer is going to be paired. That is connect. And we then go and download. So we're now downloading. And you can see the progress on that. And when we download, we get our program to work. Here we go. We're started off at 1400 hours, and it's incrementing the seconds as we go through. And that's our first simple program. Okay, we'll go on to our next project, and this will be similar. So we'll maintain the clock, but this time we'll adjust the minutes. And the coding, let's have a look. We've got we're going to use the extensions again, and we're using interrupts and the user interface. The design, well, we've already considered the layout of the screen, the LCD, and the UI. We're going to press button A to increment the minutes. So let's have a look at our software. I won't go through the construction of the whole thing, but our UI is the same as we had before, and the code is very similar. So we'll go down and have a look at that. Most of it's the same. The only thing is on the bottom left, we've got an event. That is when we press button A, which is the button for the LCD right on top of the Atom computer. When we press that, we'll change the minutes by 1 and show that on the label. Okay, so that's all the we have for the addition on that, and that should work quite well. It we should be able to reach all of our objectives with that little program. Program 2 is quite similar. The only addition is that we can adjust the minutes by pressing button A. So we've pressed it once, twice, 3 times. So we have a way of adjusting the minutes on our clock. Okay, the next one is, let's have a look at what the objectives are here. Coding, we're going to do a little bit more coding. We're going to maintain the clock and adjust the minutes as we've done before, but this time we're going to use a timer interrupt rather than a sleep. So it doesn't matter what we're doing in forever. In the loop, we'll interrupt every 1 second and increment the seconds in that callback. So here's our program, and this should be a bit more accurate because we're not going to lose time by executing the code in the loop. So that's using the timer interrupt, and it's one of 4 timers that we can use. So that's our 3 simple timers. Now we'll have a look at playing with a few more timers. We've got an objective here where we're going to schedule up to 4 timers. Timer 1 is going to maintain the clock just as we did before, and the other 3 are going to set the state of 3 circles, either, and each of them will have a separate color on the LCD, and the timer will toggle the circle color, fill in the color at certain times, and we'll have three circles and 3 timers. So the coding for that is we're going to learn about using the user interface and drawing and resetting our circles on the LCD. Software-wise, we're going to use UI Flow 2, and the extensions, we're going to use the timer. So we select that one, and we'll have extra commands available to us on the toolbox. The code-wise, well, here's our code. And we've got a little bit more. We've got to initialize 3 timers this time. They'll all have different times. And we still need to maintain our clock just as we did before. And we're going to show the hours, minutes, and seconds on the LCD. And we're going to set up our circle. So the first circle will be in red. The next circle, circle 1, will be in green. And the circle on the right will be in, will have a blue color. Okay, so that's our code for initializing. Button A will do as it did before, and the other buttons for the loop we haven't actually shown what happens here with our callbacks. But in addition to this code, we also have a callback. Here we have the timer program with the name of the program on the top line. Under that, we have the clock value of 1400 hours, 1 minute, and it's then incrementing the seconds. Under that, we have 3 tasks. The first one changes the color red on or red off every second. And the next one has a longer timing. And then we have the final timer. Timer 2 is showing blue. So we've got 4 timers working for us on this simple project. Okay, so that's the timer. And our clock, let's have a look at the clock here. We're going to show local time using the real-time clock, which is similar, but it maintains the year, month, and day of the month, together with the hours, minutes, and seconds on the M5 stack. And there's a real-time clock built into the Atom S3R. Software-wise, we're going to use a UI, which is, while it looks a little bit untidy here, it will take up the right space when we execute the program. Resources, we're going to use, this time we have to select the extensions, real-time clock. So that now that that's added, it allows us to code the Greenwich Mean Time. We can initialize our real-time clock and set up. We set the time and the GMT, and we can then access each of the parameters for the labels on the LCD. That is, we've got the year on the top. The next one is going to be our month, day of the month. then we start off with hours, minutes, and seconds. So now we don't have to set up and adjust the time. It will get the time from the real-time clock, as long as we initialize it correctly ourselves here. Okay, so that's our clock program. Here's our clock fall program, and on the bottom line, we're showing the seconds being incremented. We're just about to go over and increment the minutes. So we've got 1000 hours, and it's 5 minutes and 10 seconds. And on the line above that, we've got the date, and the name of the program is on the top line. And this is using the real-time clock hardware built within the Atom S3R computer, together with the software extensions for the real-time clock. And let's have a look. We've got a watchdog timer. So the watchdog timers are very handy if something's gone wrong with our hardware and we want to reset it. So when I was doing programming for making devices like the toll booths on the Sydney Harbour Bridge, if the micro went crazy, I had to bootstrap it or boot it again. And I used a watchdog timer for doing that. So what we're going to do is set the watchdog timer to reset the device when the program abnormally fails. It misses a checkpoint in the normal programming. And the software, the UI program here, if we have a look, we've got a special block or extension just for our watchdog timer. So we add that. That's the one we're going to work with. And the code is very simple. Here it is. We set up, we initialize the WDT, which is watchdog timer, and it's set up for 2 seconds. And I'm going to put a label while it's initializing, booting. And I'm going to wait a second. Then I'm going to have another label, or the same label, but I'll change the content of that to forever. Then I'm going to wait 3 seconds. And guess what's going to happen? It's going to reboot the computer because nothing has happened in the interval that I've set for the watchdog timer. And that could be quite handy if you have to do some programming that requires devices not to fail, but you give them a chance to reboot if something does go wrong. And of course, there could be something wrong with your program, and you can fix it later. So it's probably a good idea to log this event so the person that maintains the software can actually check out the performance of the program. It might not be software. It could be some hardware that's failed and it hasn't reached the checkpoint. So perhaps the best thing to do is to reset. And that could also be a nuisance if it just keeps on resetting. So you might also have to have an alarm, a remote alarm, to let someone know that there's something happening. Okay, so we were able to get the watchdog timer to go. Okay, so in the session, there'll be a few extensions on demonstration. The first one will be using the internet protocol called NTP, and that stands for Network Time Protocol. So after doing some testing, I've discovered that the network timing protocol for the Atom S3R doesn't work properly. And the reason for that is it doesn't access a NTP server. So while this is the program, um, we don't get the correct results. And if you want to use NTP, you have to use a different computer like the Core 3, but it will only work on UI Flow version 1. I'll also be looking at the time timer. And here is that we want to use the screen and have a countdown to show the remaining time for a task. So this is for a person who may be disabled or for a child, where you want to set up the time for an activity and then show them what time's left and when time for that task is finished. So we're going to use a dial here on not the Atom, but a dial computer. So the computer will be the M5 dial, and it will look like this. And we can set the time with the dial. And we're going to use a synthesizer unit that gives us some feedback about the remaining time and when time is completed. So the user interface will look like this. So on the top there, for Jason's timer, just under that, we've got the blocks, and they go black. Each increment will count down, just like the commercial timer. Resources, I'll be using the unit, which is the unit MIDI synthesizer, and this is the code for that. So I won't go through all of that now, but it will be on demo in our live session next Saturday. And that's sort of how you can use time and use it for activities that you want to control, that you don't exceed the time you spend on them. The next one is looking at music, and we can get one of the M5 stack computers. Let's see which one. Here we've got the core computer, and it's going to play music. And it's quite important that we get the time right for our musical score. That'll be also on demonstration. And together with using time for debugging. The way we're going to do that, we're going to measure time executing code, and the UI flow will add to our clock program another label which will show us how long it takes us to execute, but we'll also put the results onto a serial port. And here we'll be using the timer, and here's our code for doing that. So it's the same as we had before, but we've added a start time in the main loop. And what we're doing, we're finding out how long it takes us to go through most of the code within the main loop. So we have a start time, a finish time, a duration, and we publish the duration onto the serial port with the print statement, and we also put it on that final label. And we'll have a look at a desktop version of that later. Okay, so that concludes all the demos that I'll do next Saturday. And a challenge for you is that you might like to design your own scheduler where you have a start time, a repeat flag, and a priority. And you could use that instead of a real-time operating system, although this does this scheduler would do the functions. And that might be enough for your final robot program. Okay. And finally, you can turn your Atom S3R into a smartwatch. And to do that, you need to pair it with your Android phone using the Kronos app, then downloading via the M5 burner the Atom S3R smartwatch UI program. So that's what it looks like. And once you've got it loaded and coupled, you've turned your Atom S3R into a smartwatch. Okay, so that's our program for this month. And next month, we'll have a look at using the Atom S3R for traffic signals, garden control, rubbish detection, and we'll have a look at a open AI voice assistant where our Atom S3R performs that function. Okay, then we'll move on to motor drive, then onboard sensors, navigation, adding additional external sensors and servos, then a joystick. Then we'll have a look at robot communications, a Mars rover, and finally, we'll look at robots and AI. And each of these sessions will be done in a separate month. So next month, we'll be doing other projects. And that's it for me. And there'll be a couple of desktop demos that follow.